Adeyemi Oluwadimilade Deborah, the creator of Compass 7.0. And in this video, we're going to be doing correction to Neco Geography Practical 2024. Now, if you are new to this channel, make sure to check out our other videos. I know a lot of students find map work to be one of the most challenging aspects of geography, but I assure you that the moment you understand the concept, you come to love map work. And so without wasting any more time, let's get on with the video. Use the map of Bacham district to answer questions 1 to 10. What will be the new scale of the map if it is reduced to half of its original size? This question is testing your knowledge on map scale conversion, and the question already made it easy for you by telling you upfront that it's about map reduction. Remember from our video on map reduction and enlargement that when we increase the map scale, the size of the map is going to decrease. But if you still don't believe me, then you're going to see after we solve this together. The scale of the map now is given to us in bar or linear scale, as we can see here, and we have to convert it to representative fraction or RF, which the options were given in. Now this is our bar scale or linear scale. The main focus should be on the numbers after the zero, so that's 1, 2, 3. The 1 before the 0, just ignore that. So now in a situation like this, I always advise you to use your ruler to measure the distance between the numbers. Never assume, always use your ruler. When we measure the distance between each of the numbers, that gives us 1 centimeter. And since the interval is 1 kilometer, as we can see, 0, 1, 2, 3, the interval is 1 kilometer. So that means we can say that 1 centimeter is equals to 1 kilometer. Now, converting our scale to representative fraction, recall that 1 kilometer is equals to 100,000 centimeters. So with that, we can easily say that 1 centimeter is equals to 100,000 centimeters, since we originally said that the scale is 1 centimeter to 1 kilometer. And converting this to fraction, this gives us 1 over 100,000, which is the same thing as 1 ratio 100,000, but this is not the final answer. Remember the question said that we have to reduce the scale to half its original size. What we've gotten now is just the original map scale. Now remember in our map reduction and enlargement video when we spoke about case 2, when we were given the factor and asked to find the new scale. So in this case, we have our old scale, the representative fraction, that's the 1 which 100,000 centimeter, and the fraction, which is half of its original size. That's what the question asks us to do. The factor that we're reducing it by is 1 over 2. Inserting our parameters, this gives us 1 ratio 200,000. So as you can see, for us to reduce our map by half of the value, the scale increases by 2. So the scale moved from 1 ratio 100,000 to 1 ratio 200,000. But in the real sense of things, the new scale is actually smaller because if you put in your calculator, if you're not sure, 1 ratio 200,000 is actually smaller than 1 ratio 100,000. But what I mean by the scale increasing is that the value 100,000 to 200,000. So now this is our new scale once again. So reducing to half of its original size, 1 ratio 200,000. That makes the answer to this question D, 1 ratio 200,000. Now, if someone was in a hurry and stopped at 1 ratio 100,000 and seen that the answer was in the options, they would have picked option B confidently and failed this easy question. So in exams, as you're working with time, please try as much as possible to be accurate as well. Moving on to the next question. The interval of the contour line is. This question shouldn't waste time because all we need to do is find some close contour lines on the map that are numbered. That is, their height is indicated. And then we can find such an arrangement in the southern part of the map, right about here, where I've highlighted. You see the contour lines numbered 500, 550, and 600. Let me bring it out, making it easy for you to see. Now, from this, it should be clear what our answer is, that the contour interval between these lines is 50 meters, and that makes option A the correct answer. Also, in the northeastern part of the map, we have the contour lines 700, 750, 800, and that still further reinforces the answer as the contour interval being 50 meters. The distance from Bacham to Manga as the crow flies is approximately, now we've been saying repeatedly in our previous correction videos that as the crow flies simply means distance in a straight line. So firstly, we draw our cardinal points on the two places in question, Bacham and Manga, and then we draw a line connecting them. After this, we measure the distance between the 2 points. We measure a straight line, and that gives us 7.7 centimeters. Now take note of the difference in units. We measured in centimeters, but our options are in kilometers. And that's because what we measured is the map distance, the distance between two places on the map. But we need to find the actual ground distance. And for that, we need to convert it using our scale. So recall that our scale, as we saw in question 1, is 1 centimeter to 1 kilometer, or 1 ratio 100,000. Therefore, 7.7 centimeters is equal to 7.7 kilometers, and that is approximately option 8. So if someone just approximated the answer that they got, 7.7 centimeters, and picked 8, that is option B, without going the proper way and converting to map distance, they would have been able to get away with it with a question like this because of our scale. But if they had a different scale, let's say 1 centimeter to 2 kilometers, then they wouldn't have been so lucky. So always learn to complete your work to avoid errors. Which type of trigonometrical station is represented on the map? Firstly, let's find the trigonometrical station before we start classifying it. So if we look at our map, we can see the symbol trigonometrical station on our map key as a triangle with a dot inside it. And it usually has numbers written beside. A trigonometrical station is a marked point on the ground that helps surveyors to know the correct height and location of places when making maps. And it's usually denoted by a triangle with a dot inside, as we previously said. Now, the next thing to do is to identify the trigonometrical station on the map. And if we look closely, we can see it in the northeastern part of the map. Now, onto the classification. When I checked the required textbook, they said there were three types of trigonometrical stations: primary, secondary, and tertiary trigonometrical stations. But the difference in their symbols wasn't stated clearly. But on looking at the map key of previous Neco examinations, the answer was clear. These are pictures taken from recent Neco practical maps. And according to it, we have three types: primary, secondary, and minor trigonometrical stations. And I'm sure you can easily tell what the answer is going to be now looking at their symbols. So for a primary trigonometrical station, it's a triangle facing the right side up with a dot inside, while secondary is an inverted triangle also with a dot inside, while for minor trigonometrical station, we have a circle with a dot inside. So now comparing once again, we can clearly see that the answer is option C, primary, since the symbol on our map is an upright triangle with a central dot. This corresponds to a primary trigonometrical station. Question 5. Bartram settlement is located on a. Firstly, let's find Bartram settlements, and we can see it in the center of our map. The answer to this question is option D, a pass. Now let me show you what it means. But if you watch our last Neco correction video, that is the one for 2023, then you should have gotten this question because there was an objective question that made us explain this feature in detail. We had an image similar to this in the previous correction video, but I have to modify it to try to recreate Bartram settlements. A col is simply a low point or a depression between two higher peaks, as we can see here. But if a call is actively used as a transportation or migration route, then it becomes a pass. Now, looking at Bartram settlement here, we can see that it's located between two peaks, and the road that passes between these two peaks indicates that it's used for transportation. So that means that this is not just a call now, but a pass. So I'm sure that it's easy for us to see the difference. If there was no road here and this was just plain that it was just a settlement located here, then this would have been a call. But the presence of this road indicates that this place is also used for transportation. That means it's a pass. The direction of flow of River Jamtari is, first let's identify this river. Over here we see River Jamtari. So we can see how it flows. Now let me trace it out to make it bolder. So again we have River Jamtari. And then let's write our cardinal points to make it easier. North, east, south, and west. Remember, east comes before west. Now, to determine the direction of flow of the river may seem like an easy task, but you actually have to be careful to avoid falling into traps. And that is because if I decide to determine the direction of flow by just looking at the general layout of the map, then I would say that River Jamtari is flowing in the downward direction, that is southwards, and to the right, eastward, and then pick option D, southeastward, and that would be very wrong. The correct way to approach this question is to remember that rivers always flow from highland to lowland. So now let's look at the contours to determine which area is highland and which area is lowland. Focusing on the contours crossed by the river, let's zoom in. So now looking at the river Jamtari, we can see how it crosses two contours. One here and another one just below it. 650 and 600. Now let me make them bolder. So we have them 650 contour line, it crosses it here, and the next contour line is 600. So that means that the river is going to move from highland to lowland, that is from 650 to 600. So that means we can say that River Jamtari starts or originates near Bacham settlement around here, the 650 contour line, and moves towards the left, westward. And as it moves, it slants slightly downwards, and that is towards the south, which makes option E correct. So it moves southwestward. It flows towards the west, and on its way, it slants slightly downwards, moving in the southward direction, making option E correct, southwestward. So as you can see, never assume from the general orientation of the map. If we had picked option D now, that would have been very wrong. But we can't say that the river is going to flow from 600 to 650, defying gravity. No, it doesn't work like that. The length of River Jamtari in kilometers is approximately, again, another question relating to River Jamtari, but now we need to calculate the length of the river. So let me highlight the river once again. To measure, take a piece of your white thread and place it at one point of River Jamtari. Extend the thread throughout its whole length and use your pen to mark the end, and then stretch the thread over your ruler. On measuring, I got 11.3 centimeters. Remember, this is just the length on the map. We need to convert it to actual length on the ground. And for that, we need to recall our map scale, which is 1 centimeter to 1 kilometer. This means that the actual length of River Jamtari is 11.3 kilometers. Since we're following our scale 1 centimeter to 1 kilometer, so 11.3 centimeters will be equals to 11.3 kilometers. And approximately that is option B, 11 kilometers. Which of the following settlements are intervisible? If you've been following our correction series, then you should understand the concept of intervisibility perfectly and even know how I like to explain it. But for the sake of our new subscribers, let's quickly run through the concepts. Intervisibility is the ability to see one point from another. The reason why a settlement will not be intervisible is the presence of a high contour between the settlements or the places in question, and that's a very important point. If we look at our illustration and we take our reference from house A, what can we observe? From house A, we can see house C, and hence we can say that house A and C are intervisible, while house B cannot be seen from house A, and so house A and house B are not intervisible. Now, since we get the concept, let's go back to the question. Now we know the question is simply asking us which of the following pairs of towns can be seen from the other. So let's evaluate the options one by one. Option A, Kachon and Nubi. As we can see, they are not intervisible, and that makes option A wrong. Option B, Lande and Kanku are not intervisible, and that also makes option B wrong. Option C, Manga and Gotel are not intervisible, making option C wrong as well. Option D, Manga and Kanku are also not intervisible, and that makes option D wrong. Option E, Manga and Nubi are intervisible, and that makes option E correct. As we can see, most of our options are not intervisible because they pass the low points between the two peaks where Bacham is located. That is the pass, which also lies on a ridge. And Manga and Kanku are also obstructed by some hills. But Manga and Nobi do have a few contour lines between them. But if you notice, Nobi is on a slightly higher elevation. So it's like you're looking up a little hill without any obstruction in between. So the people in the different settlements can see themselves. And this makes option E accurate, that both Manga and Nobi settlements are intervisible. Can you see any other settlements that are intervisible? Apart from my answer, you can type them out in the comment section below. Now make sure to always read your questions carefully, because in our previous correction video, Neco 2023, they asked a similar question with a twist, which was the pair of settlements that is not intervisible is. So in that case, the question was asking which of these pair of towns cannot be seen from the other, which is not the case in this question. So in exam, please don't assume. Read your questions carefully. The bearing of Manga from Bacham settlement is. First, let's identify the settlements in question and place cardinal points on them. And now we draw a line connecting the two places. The next thing is to place our protractor. And for that, we need to take notes of the settlements after the word from. The bearing of Manga from Bacham settlements. So that means our protractor is going to be on Bacham settlements from Bacham. So that from is very important. And then we need to take our bearing starting from the north all the way to the line that we've drawn from Bacham settlements. I decided to expand it to make the question easier to explain for some people who don't completely understand the concept of bearing and distance. So we are going to take our bearing from the north. Our protractor will be placed on Bacham district like I did earlier, but now I'm not going to place it there, but rather magnify it and put it beside, because this protractor is not transparent and it's going to block the line. So now just imagine that our protractor is already placed on Bacham district, and this is the line that we've drawn here. So starting from 0 all the way to the line, we have 9 degrees. So starting from this 0 all the way to the line, we have 9 degrees. As you can see, it's just before 10 to 9 degrees. And that is the angle here, 9 degrees. Now to get our bearing, all we're going to do is add 180 degrees, which is the angle on a straight line, to the 9 degrees that we've gotten earlier, and that is going to give us 189 degrees. Now we can also use another method. Now moving back to our protractor, taking an angle all the way from the other end, from this 0 on the other end, and moving all the way to our line here, that is going to give us 171 degrees. So imagine our protractor is still placed back here, and we're taking it from this place, from this end where the other 0 is here, all the way back to the line. That's going to give us 171 degrees right around here. That's going in this case now it's not before the line, now it's moving after the line. Since 170 is here, then 171. Then we're going to subtract this from 360 degrees, which is the sum of angle at a point. And that's also going to give us 189 degrees. So please take your time to go over this as many times as possible. Now our answer is going to be option B, 190 degrees approximately. Now, as we said earlier, the bearing of Manga from Bacham settlement is 190 degrees. This is our last objective question. With evidence from the map, the people of Bacham are most likely to engage in. For this question, we just need to look for something around Bacham that would tell us the likely occupation of its people. So let's zoom in. We already said that Bacham settlement is at the center of the map. Now look closely at Bacham settlements. Take note of the things around it, or what could possibly tell us what people in this settlement engage in. You can see a symbol here. Nothing really much around it. You can also see a market in the city, in the settlement, sorry. Around Bacham, as you previously spotted, we could see some symbols, this circle here. And from our key, we can see that these circle symbols mean a light forest. That's just one here. Then, if we look a bit further, we can see some lines here. From our key, they mean scrubs. But for me, I would say that the most prominent feature that tells me the main or primary occupation of people living in Bacham settlements is the markets, MKT, which means market from our key. And based on this, my answer will be trading, option E. Now, I know that some people might have doubts because for questions like this, the answers are usually farming, fishing, mining, or some other occupations. But let me give you some reasons why the answer should be trading. First, remember one of our earlier questions where we said Bacham is on a pass, which is simply a low point between two peaks that is used as a transportation or migration route. Bacham is also at the center of our map, and not only that, almost all the settlements connect directly or indirectly to Bacham. And Bacham also has the only market in the whole district. And so combining all these points, road convergence on a pass, the market symbol, and its central accessible location, the primary occupation supported by map evidence for Bacham is trading. I believe that if they wanted you to pick farming, they would have made the scrub or cultivation symbols a bit more concentrated around Bacham. So in this case, it's possible for us to say that they may engage in some secondary activities like farming, but the most likely occupation they're going to engage in is trading activities. Now let's move on to practical and physical geography. Study the map extract of Sorel SW provided on a scale of 1 ratio 50,000 and answer the questions that follow. 1A. Draw an outline of the map to a scale of 1 ratio 150,000. On your new map, insert the minor road, rivers Mayor Kundul and Mayor Pandi. Now let's quickly look at our map so that we can identify these features that we're supposed to draw on our new map. Now this is a picture of the map, Sorao SW, Neco 2024. Let's take a look at the whole map. We also have the map key at the bottom. So the question asked us to insert the minor road. And if we look at the map, the only road you are seeing is this long, extensive road that even branches out here. And if we check our map, that's the minor road. And also rivers Mayor Kundul, and see around here, that's all the way from the top, Mayor Kundul and Mayor Pandi that joins it. So now let's go back to our question. Now we have original map scale as 1 ratio 50,000 as told in the question and as we saw on the map. And we're asked to draw a new map with the scale 1 ratio 150,000. So since the scale of the map is increasing from 50,000 to 150,000, that means that the size of the map is going to decrease. Remember the inverse relationship I explained in our map reduction enlargement video. So now we know that it's map reduction, we need to know what factor we're going to reduce the map. So let's recall the formula. This is from our map reduction enlargement video. Whenever we're given a new scale and asked to find the factor, then this is the formula that we make use of. Old scale over new scale. And you can use the word on to help you remember the numerator and the denominator. If you get a fraction, then it's going to be a reduction. And if you get the whole number, that means it's an enlargement. Another thing to note is that when using the formula, ignore the 1 in the ratio, because using it is going to give you the inverse of the correct answer, which is wrong. So now let's solve for our question. Since we got a fraction, after using the formula old scale over new scale, 50,000 over 150,000, remember we ignored the 1 in the ratio, that gave us 1 over 3. And that's a fraction, so that means it's a map reduction based on the formula that we saw earlier, and we've already deduced that it was a map reduction following using our inverse relationship. Now we know that the factor by which we are going to reduce the map is 1 over 3. So we're reducing the map to a third of its original size. If we had done 1 ratio 50,000 divided by 1 ratio 150,000, we would have gotten 3 instead of 1 over 3, and that would have been very wrong. They will never ask you to enlarge the whole map because nobody is going to give you a paper that big if you want to enlarge an already big map. Just imagine now you are giving your normal exam map, because I know most of you might have, if you've not seen it, you might have seen your seniors, maybe your teachers in school holding the actual big, you must have seen the large size of the examination map. Now imagine times three of that paper, of that map. Nobody's going to give you that to do in exam, so don't worry. The only way you'll be doing a map enlargement in exam is if you're dealing with a section of a given map. Now I'm sure those of you that have done past questions might have seen a question like draw a new outline of a section labeled ABCD. So in this case, you're going to be with a map enlargement. But if you're asked to redraw a whole map, it's going to be a map reduction like we have in this our case. So now the length and breadth of our map is 2 centimeters. And if asked to reduce it to a third of its original size, that means that the length and breadth of our new map will be 10.7 centimeters. So now let's draw the outline of our new map. 10.7, which is 10.7. Also forgot to mention that since they have the same length, that means our map is a square. Now the length of our new map is ready. All we need to do is insert the required features. But before that, we need to draw a grid for the map, because this will allow us to place the features that we were asked, that is the minor road and the rivers. It will allow us to place them accurately. Now the grid boxes shouldn't be too small, as that will make plotting the features time consuming. And at the same time, it also shouldn't be too big, or it will be difficult to accurately position the features on the map. So now the grid of our new map has 9 rows and 9 columns, and the same will be done to our actual map as well. So this is our map, 32 centimeters, 32 centimeters, and I've now drawn the grid lines on our map. Also the same number of 9 rows and 9 columns. Now we can insert the features, the first being the minor road. Looking at the map, there's only one road, one long road. We can see it here, and it continues here and branches out. And this road is just a plain road. It doesn't have any stripes. It's just a plain white road. And this corresponds to the minor scale that we see on our map key. A plain white road is not red or brown and it doesn't have stripes. To insert the road in the correct position, all we need to do is follow the grid on the map and place the road in the exact same location onto our new map. And it should look like this. Now, as you can see, we've been able to place a minor road following the grid on the map. Next, we have to put our rivers, River Mayo Kurndul and River Mayo Pandi. And we're also going to follow our grid to ensure adequate placement of the rivers. And that's going to look like this. So now we've drawn our minor road and the rivers, and we're done with question 1B, but I need to add some finishing touches. And now we're done with answering question 1A and B. Please, the only reason I use colored pens is to mark out the features, to make the explanation clearer and for aesthetic purposes. In your exam, use pencil for everything. Both the road, the river, make sure to use pencils for everything. Moving on to the next part of our question. Question 1C. With examples, mention 4 economic activities that are practiced in the map area. Now, looking at our map once again, now we have to look at the map to try and get the economic activities of people living in this area. So now looking at the whole map, let's zoom in even further. You can see all these symbols that basically fill the whole map, all these symbols. And now looking at our key, they correspond to scrubs. Looking at the map once again, we can see these black zigzag lines. You can see them here as well. They're not as much as the scrubs that we just saw. We still have a good amount of them here. And if we go down to our key once again, these black zigzag lines indicate scattered cultivation. Moving back to our key, we can see these gray patches along the roads, all these gray patches. And looking at our key to compare, they are the built up areas. We can also see the road with this minor road that we drew, and even these dashed lines, which mean minor paths. We have minor paths here. Don't forget the river as well. That's also going to be important in determining the economic activities of people living in this area. And even this dash line, these blue dash lines we can see towards the bottom of our map. Everything is going to be important. So now I'm sure you should start thinking or you should try to start guessing the occupations of people living in this area. And even looking at the top, this Sorrel districts, we have DISP, MKT, school, veterinary clinic. So if we go to our map, here we see DSP dispensary, MKT markets, SCH school. So now let's interpret everything we've seen. I'll try to arrange them based on the order of importance, what I feel are the main activities. Firstly, we have animal rearing. The presence of scrubs provide grazing areas for animals like goats, sheep, cattle, and I'm sure you saw how the whole map was filled with all these scrub lands. And because of that, we can deduce that animal rearing should be the major activity of people living in Sorrel districts. The next is fishing. The presence of many rivers encourages fishing, an example of rivers being River Mayo Kurndul and even River Mayo Pandi. We also have a lot of smaller rivers that span the whole map, those tiny blue lines. Now, the next occupation or economic activity of people living in this area is farming. The presence of scattered cultivation, those black zigzag lines that span the map, also tell us that people living in this area engage in farming. And also the fact that the map has good drainage, as evidenced by the numerous rivers, also support the farming occupation of people in this area as well. Number 4, transportation. A lot of people don't see roads as special features, but the presence of roads connecting settlements suggests that people living in this area will engage in transport, at least for the purpose of trading, for movement of goods and services, and even to get to school or maybe even visit the dispensary that is there. So the presence of those roads and the minor paths suggests transportation. All those grey patches that are shaded beside the roads are called built-up areas, and a lot of people don't know the significance. But built-up areas on a map suggest places with high population. It shows development compared to scattered rural homesteads. And where we have a large number of people, we should expect a lot of trading and commercial activities going on in such an area. Social services. The presence of schools, dispensary, and a veterinary clinic, as we saw around the rural settlements, will provide employment opportunities for people in education and healthcare sector of these districts. Now, people could be employed either as maybe teaching or non-teaching staff, and don't forget that people who run the dispensary as well, and even the veterinary clinic. And just like that, we have six economic activities from the map. Now, let's move on to the last question. Describe the drainage of the mapped area. Now, let's look at our map once again. We were asked to describe the drainage of the mapped area. So we can already identify this map, this River Mayo Krundul that we've drawn earlier, and also River Mayo Pandi. Those are not the only rivers that we can see on the map. Those all these tiny blue lines that you can see that are different from the brown contour lines, all those tiny blue lines are rivers. And if you even look, you can see some of them are labeled. Look at this one. And these blue lines span the whole area of this map. We can see that they are almost covering the whole part of the west portion of our map. And looking at the bottom of our map, we can also see a lake, marsh here. We can also see some dashed lines here too, some dashed blue lines. And if we go to our key, that means these areas are liable to flood. Let me zoom in. These areas are liable to flood. These dashed blue lines. So looking at the map once again, these tiny blue lines, the rivers. Now let's go and answer our question. When talking about the drainage of a river, a lot of points need to be discussed. Not just the pattern of drainage, you also have to indicate that the rivers that are present there, the direction of flow of the main river, presence of other water bodies present, like maybe lakes, marshes, and a lot more things. And I believe this concept deserves a video of its own. But for now, the first point is that River Mayo Krundul originates from the northeast and flows southwards, where it forms a confluence with River Mayo Pandi. Now let's quickly look at this in more detail. Now we can see this long river here is River Mayo Krundul. I'm sure you remember it because we drew it on our new map. We can see how we moved from 1050. I have to make the contour lines a bit bold for you to see. 1050, 1950, 900. So we can see as the contour lines are decreasing as we move down the map. And remember that rivers flow from highland to lowland. So with that, we can easily say that River Mayokrundul is flowing from north to south. Let me zoom in once again. Okay, here we have the 1050 contour line, then 1950, 900. I'm sure you all saw the tiny blue lines that basically covered a good portion of the map. And because of that, we can say that majority of the map is well drained due to the numerous rivers that run through the map terrain. Now let's talk about the drainage pattern of the map. The map has a dendritic pattern, meaning a tree-like arrangement of rivers and tributaries. I'm sure that you can see the rivers towards the east of the map that we drew earlier, the very bold river, River Mayo Krundul, and also the tiny tributaries that come from the west. Those tiny blue lines, they may look a little gray, but just know that these light blue lines that are different from the brown contour lines are tiny rivers. Okay, let's zoom in, even though I've shown you before, but let's just look at them once again. So these blue lines are different from the brown contours. All of them are rivers. Now the main river, River Mayokrondol, acts like a trunk, while the tributaries join it at various angles like branches of a tree. So it looks sort of like this. The trunk, the River Mayokrondol, and all these tiny rivers that join it look like the branches of a tree, meaning that this is what gives it the dendritic tree-like pattern. Remember I told you earlier that those blue dashes mean the area is liable to flood. This place is also a lowland and hence there's accumulation of water from these larger rivers that are flowing, that we see flowing southwards. It is poorly drained in the sense that the water that is there doesn't flow away easily and these areas become waterlogged and even form marshes or swamps. A marsh is written here as evidence of this. And with that, we are done with this question. As you can see, there are lots of things you can write on drainage of the map, not just the drainage pattern. You can even add the stages of the river, the presence of other water bodies like boreholes, lakes, presence of other features like meanders as well. This map even has a lake in this portion. We can see it written down here, a lake. And with that, we've come to the end of the video. Please take your time to understand any of the concepts that you didn't find quite easy to grasp the first time. If you have any topics that you want videos on, you can type them out in the comment sections below. Make sure to like, share, and subscribe. Thank you.